Hi, I'm Tanya Gratz with the Greene County Land and Water Conservation Department, and today I want to show you about a simple demonstration that you can do at home showing groundwater. So the supplies that you're going to need is a small plastic tub, a plastic cup, a syringe or a turkey baster, another cup or pitcher to put water in, some sand, and water. This is colored for demonstration purposes today. So with the cup, I want you to make lines to show different levels, because this is going to represent your well in your demonstration. And then I took a pin and poked holes along all of these lines for letting the water in. Okay, so what I had to do was dig a hole in the model and put this and place your well down to the bottom of the sand. So then you're showing your well, and then you have an open spot on one end to kind of show the surface water. This will make more sense once I pour the water. So I'm going to pour the water so it's raining or it's melting snow. And we're getting some erosion, lots of fun. More I need here. I'll wait for it to kind of settle out. So in the well, you can see some blue or green kind of coming in there. That's the water coming into a well. So this happens on your wells at home or the public wells that we have, that there's different layers in the ground that hold water. So groundwater is actually the water within the pores, the air spaces in sand and rock and the soil that we have underground. The surface water is a visual to where the groundwater is exposed, or what that water level is. And so if you look at this demonstration, you can see that if this was our lake or pond, what that level is, that the same level is happening inside our well. So the groundwater is that same, it bears the same, it's level on the landscape. Now if we draw down our well, let's say we're pumping, we have a house where we need to use it for regular household activities. We're drawing the water out of the well. So we've decreased that water level in our well, but it's actually filling back up. That we see we have 20 to 30 times more groundwater than we see that we have in surface water, which is important because that's where most of us are getting our drinking water that are watching this, is from our groundwater. Some cities do get their water from surface waters that they take off of a lake or a stream or a river and filter it, which is pretty expensive to make it drinkable for people. So we'll draw some more out. We'll see that change, that originally it wasn't very blue. Now it's starting to come back in more blue. So some places their streams are going dry or their lake levels are going down. Well, the cause of that is that there's more pumping out of wells, out of that groundwater. They're taking that groundwater out, and it's not being able to replenish the groundwater fast enough in order to maintain that surface water. Groundwater moves very slow, so it very slowly percolates through the soil and rocks and gravel and into the groundwater, or to the aquifers. So groundwater can be days, weeks, months, years, millennial old. the farther and farther down you go, the longer it's taken for that groundwater to get there. And hopefully it's cleaner too. So when we have surface water, we're taking that's suspect to all of the recent contaminants and pollutants that might get to that. So it's very important for us to protect our groundwater and surface water to make it as clean as we can keep it. Most people have their own wells. So if you go out and look in your yard, you're likely going to find something like this. This is the top, or what would be above ground, of your well. So this is an indicator that that is a well. And so a well is a direct conduit or a straight pipe down into the ground. It goes down, 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 150, 200 feet sometimes, maybe even more, depending on your location. And so in that hole that they drill, they line it with metal to keep the upper aquifers out of the well, and then so they can go down into the very clean, deeper aquifers to get the water. And so you can see that there's, in that hole that they drill, down through the rock, that the water, once they don't case it, this is called casing. They don't case it all the way down to the bottom, but sometimes they case it quite a ways down to keep the aquifers separated. And so water in these aquifers will fall into the hole, and so then that's what fills up your water. So like when we were doing the demonstration, that is what is filling it up based on those other aquifers in the ground. And so the water goes into the pump and goes up and comes out your faucet. Pretty exciting. Sometimes there's wells out in the country that haven't been used for years and years, like under a windmill, or maybe there was an old house there with a cistern and it's not been properly abandoned. And that's when we step in and we try to help people get cost sharing to get that fixed. Because those old wells, they could have rusty pipes, people could be forgetting about them and throwing junk in there. And all of that junk in that is going to rot away in the water, and then that can contaminate that aquifer that water or that the well goes down into. So that is not properly abandoned, or it could be possibly contaminated. And so when we get involved, we try to properly abandon it, which is pulling the pump and all the pipe out of the hole, and then then the well driller pours bentonite, which kind of looks like gravel, but it's a highly expanding clay, into the hole all the way to the surface. And then that water that's naturally in the hole gets into the clay and it makes it expand. And so then water, it can't pass through. Contaminants cannot get into the well. So that would be protecting our groundwater. And then this is another this picture behind this model is showing, like, it looks like bedrock, which water moves through these cracks. Either it can go down, they might find another lateral crack to go on, and they might find another vertical one to go down. That water seeps very slowly through this. But this is what an aquifer looks like. That it's not just a big pond or a big open area underground, that it's actually broken rock or sand or gravel that water can percolate slowly through. And so that's why we should protect our groundwater.